Hello everyone. So today we will cover the new chapter 4, which is friction. So this is the part 1. Okay, this is the topic outcomes in which you are expected to learn and about law of friction and the application, problems involving dry friction, and the second part later on you will study on the wages. So the expected from you is that you are able to introduce the concept of dry friction, analyze the equilibrium of rigid body subjected to friction, then present specific application of frictional force analysis on wages. Okay, the objective of this topic is to understand the characteristics of dry friction, to draw a free body diagram including the friction force, then solve problems involving friction. So the application of friction, for example, in brake system, okay, brake system of a bicycle, car, or any other vehicles. So for example, it is important for you to understand the frictional forces involved in the brake system. And for an applied force on the brake pad, how do you determine the magnitude and direction of the resultant friction force? So in this topic, you will be able to calculate or determine the magnitude and direction of friction force. Okay, for example, this application, considering the box was pushed, okay, as shown in the figure here. Okay, how can you determine that the box will slide, tilt, or stay in static equilibrium? Okay, how much force that you think you need in order for you to make to push the box so that it will slide, and how much force you need in order to make the box tilt, or what is the minimum force that you need in order to make it move, okay, not or so that it will not stay in equilibrium. Okay, what physical factors affect the answer to these questions? So I will later share with you the YouTube video, okay, in this link here. So what are the factors? So you will see that there are several factors which affect the movement of this box. Okay, characteristics of dry friction. So for example, for the box in the previous slide, what are the factors that affect the movement of the box? Whether the force exerted by the person pushing the box, or the weight of the box, or is it the surface that in contact with the box with the floor. So there are some of the example that affect the factors that affect the movement of the box. Okay, so we'll see the theory of dry friction. Friction is a force or resistance acting on a body which prevents or retards slipping of the body relative to a second body. For example, you can see from this figure here. So you consider effects caused by pulling, okay, the P, okay, horizontally on a block of uniform weight W, which is resting on a rough horizontal surface. You can see that the force P is pulling horizontally, and weight W is pulling downwards, okay, of the box. And there's a rough horizontal surface in which it is the friction which resists, okay, or prevent the body to move. Okay, so that is a friction. Okay, what is frictional force? Frictional force act tangent or parallel to the contacting surface in a direction opposing the relative motion or tendency for motion. You can see that the applied force P is horizontally to the right, okay, then the block's weight W downwards. Then you can see the force friction force is acting along the contacting surface, okay, parallel to the surface. And there's one more force, which is the normal force, which is acting upwards, perpendicular to the surface, okay. So the normal force is must act upwards, okay, to balance the W, to balance the weight of the box, while the frictional force must be acting opposite to the motion. If the force P is going to the right, which makes the box move to the right, then the frictional force must be acting to the left direction, okay. Okay, this is close examination. If you zoom at the surface, at the surface of the box and the contacting surface on the floor, okay, we can see that the frictional force is acting to the left, and the normal force is acting upwards. Then it caused a resultant. There's a resultant force from this force friction and the normal, which is the R, okay, that is the resultant acting on the body, right? So in equilibrium, when the body is not moving, okay, the body is in equilibrium, then the force friction equals to the applied force P, while the normal force equals to the weight of the box. And in moment equilibrium about point O, okay, there's a point O over there, you can see that the W moment is the force times the distance, so W weight times the distance x to the point O, and then you can get n equals to the force P times the height h, okay, then you get the x. That is how you measure where is the location of your normal, yeah. Okay, so what is impending motion? Okay, cases where the surface of contact are rather slippery, meaning that the box or the body is going to move, is moving. So the maximum friction force is attained just before the block begins to move, meaning that when the body starts to move, then it is called impending motion, okay. Then you can use the limiting static frictional force Fs equals to the coefficient of static friction, okay, mu s times the normal of the body. So Fs equals to mu s times the normal, okay. Then you usually in the questions it will let you know if the situation is if the box is begin to move or when it is in impending motion, then you use this equation, okay. So the box the block verge to sliding, you can refer to the figure here, okay. Then you can calculate, okay, the resultant of the frictional force, okay, the R, using the pi angle, yeah. This equation you can use the coefficient of static friction mu s. You can use the tangent arc tangent, okay, then of the coefficient to get the angle, okay. If the block or box or the body begins to move, then it is in motion. Then you can use the frictional force of kinetic frictional force of a moving body, okay. Then you can use the coefficient of kinetic friction, okay. Then you use Fk equals to mu k times the normal, right? So you can use the angle of kinetic friction is phi k equals to arctangent of the mu k, right? So you can see the difference that if the body is about to move, before it's moving, it's about to move, then you use static frictional force Fs, yeah, and mu s. If the body begins to move, then you use kinetic frictional force and kinetic friction coefficient, yeah. Okay, this is a summary. Frictional forces is categorized in 3 different ways. First of all, F equals to P where the equilibrium is maintained, okay, where the body is not moving. Then the friction equals to the applied force. The second category is when the body is about to move, then the force equals to static friction, yeah? Okay, then when the body is moving, okay, then you can use and then the force is equals to the kinetic frictional force. Okay, so this is how to determine the theta s, okay, the angle in which at which the block or the box is about to move, okay. So you can see that from here a block with weight W is placed on an inclined plane, okay, if it's inclined. So the plane is slowly tilted until the block just begins to slip. So how do you know what is the angle at which this plane is the minimum in order to make sure that the block begins to slip, okay, begins to move, So you can see that analysis of the block just before it begins to move is you can use the equation for static frictional force Fs, equals to the mu s times the normal of the body, okay. Okay, so this is how you determine the theta s. Okay, for this figure, you can see that it is tilted with an angle theta s. Yeah, so that's why your x and y axis will be tilted as well. Okay, following this angle, so it will be your x and y will be like the red lines. Okay, so if you refer to the figure, then you will have weight. Okay, weight will be divided into x and y component. Okay, x and y component, W sine theta and W cos theta. Then from there you have your normal, okay, and also your friction force, in which for this case the block is about to move. When it's about to move, it will be moving downwards, okay, it will be moving to the left, yeah? When the motion of the block is to the left, meaning that the friction force will be to the right, opposite direction of the motion. So that's why the Fs is going to the right direction opposite to the motion, okay, meaning then the normal force is usually parallel to the surface of contact. So that's why it's tilted as well, following the y-axis, okay. So using the two equations Fx and Fy equals to 0, okay, since it's in equilibrium, it's about to move, okay, you can get mu s. Mu s equals to tangent theta s. Then you get theta s equals to arctangent mu s. So this simple experiment is to find the mu s between two materials in contact. But usually the question will give the value of mu s in order for you to find the theta usually, okay.